Hi, my name is Buzz Hayes, and I'm the global lead of media and entertainment solutions for Google Cloud. And then we have a very special guest here today, Dan Lin, who is the Vice President of Infrastructure Services at ViacomCBS. We're here today to talk about content migration strategies to cloud. Now, as you all can imagine, we're experiencing some fairly challenging market conditions at the moment. So, a lot of media companies are starting to look into their archives as a way of finding material to monetize while we're on a hold pattern for other productions to be launched. So, we have a number of companies that are looking into their archives to find content to license to other people, to stream on their OTT platforms. And because of these delayed content pipelines for new productions, there's a lot of interest in finding gold in these archives. So people are looking back into media archives of all kinds, and that extends back beyond digital media. It actually extends back into analog media, which is something that we'll talk a little bit about today too. Our definition of media and entertainment is everything, whether it's film, video, audio tape, photographs, documents. They all qualify, and they're all finding new relevance in this day and age. So we find that with a number of sports leagues, there's a lot of interest in trying to leverage older content. People love to watch highlights of older games. So we're finding that across all sports, which is fantastic. We're also seeing that there are a number of new streaming entities that need more content to put onto their channels. And legacy content is one of the backbones of some of the bigger studios like Disney Plus, for example. They have a very extensive archive, and they've just started to scratch the surface, actually. So digging into their archives and finding ways to monetize these older titles it couldn't be better timing. Same with Apple and other folks like Netflix. They're really looking for ways to leverage older content as we wait for newer things to be produced. Now, the traditional methods of digitization and storage are fairly laborious and somewhat costly, very labor intensive. So, what we find is that in cloud, there are a number of ways that we can help people migrate their collections to cloud. And that includes media in any form, as I mentioned. There's a lot of analog media out there, which is difficult to monetize, obviously, until it's in digital form, until it's cleaned up, until it's made pristine and made available to the public. So we want to make sure that we have enough tools available for folks in cloud to be able to ingest this material, to convert it to the proper digital formats, and then they can start to bring this content to market. As you can see here, 42% of media CIOs are struggling with managing their content in general, and this is pre the current conditions of COVID and the environment within which we're not producing new content. There's a lot of archive content out there that hasn't been monetized. The analogy is like an art museum where over 80% of the collection is typically in storage and the public never sees it. Some of these media archives are quite substantial, and a lot of their material sits behind firewalls where people can't see it. So now is an opportunity to start bringing some of that forward. Now, there are some legacy digitization capabilities out there in the world, and we need those in order to get material off these analog forms like videotape and film and audio, for example. Especially with film. Film is a difficult process because it can be done in slightly less than real time, and videotape is limited by the fact that we can only digitize in real time. So for the 100 million hours of videotape that might be out there for any given entity that wants to digitize things, it's going to take 100 million hours to digitize that. So we have some significant challenges ahead, but the idea is to bring all of this material into cloud so that it can be then monetized and leveraged to increase the value of these archives as we go forward. So as an example, we did a project recently with the New York Times where we helped them with their photo archive. They have one of the largest photo archives in the world, and the archive goes back to the beginning of photography. And so we used a number of our AI and ML tools to help the New York Times to find information about the photographs, not only the visual information, but also by reading the information that was either handwritten or typed on the back of the photos about the uses, the locations, who might be in the photographs, and then created a database within which they can search this material at lightning speed. So in the past, it might take a few months for someone to put together a story, for example, where they wanted to do a photo essay or a photojournalistic exploration of a specific subject. They would have to hire an archivist to go and through the files manually to find these photographs, to find the individuals they're talking about, which may not be tagged appropriately, and then send those out. So we've gone now from the manual process to a much more automated process with a very robust database, which allows people to really cut the amount of time it takes to get these stories out to the public. So we're seeing significant increases in the speed from many, many months now to a matter of days to be able to leverage the content. So this is just one example. Now, archive migration within Google Cloud, we look at it basically as three distinct phases. The first phase is the digitization phase. We have to get this material into cloud. Now, some of it may be digital born already, especially modern motion pictures and television. They're all shot natively digitally. In fact, most all of the workflow itself is digital. There's still a few that shoot film, but primarily it's going to be a digital workflow. Those files are very easy to move to cloud. But once you start talking about other media types, then the idea of ingest into cloud becomes a bit more labor intensive. There are more steps involved, and we'll outline some of that we're helping with in this presentation. There's also a quality control aspect to this. There's a lot of media out there, and quality control really requires human eyes to really make some decisions. So we're helping those human eyes by leveraging some of the AI tools we have so that people can have basically a checklist to go by. So when AI finds something that might be suspect, or some quality control software finds something suspect, we can put a list together and put it in front of the people who need to look at this with their own eyes and make those decisions for themselves. So it's a much simpler process rather than having people look at every single frame of every piece of content. On the generate side, once we get this material into cloud, whether it's digitally born or started as an analog videotape and then was digitized, we create proxies for that, which are very important for a few reasons, primarily because we need a reference copy, something that we can look at, that we can use to search for material. So the core of many media asset management systems is a proxy file, and oftentimes the metadata that goes along with that is the way people are able to search these databases. So we, during this phase, leverage all of the AI and ML tools we have to be able to provide intelligence to this data through what's found in the picture, through speech to text. We can do sentiment detection. We can do celebrity recognition. We have a number of different ways where we can build a very robust database, which makes it very easy to search these mountains of information and make intelligent decisions on which content we might want to put out there on streaming channels, for example. Indexing the media is extremely important, and we have a tool that we'll talk a little bit about here that's called Video Search, which is a new tool that allows us to apply all of the machine learning and AI tools that we have as a single command line. It will then build a database of all of this metadata, and then we can surface that data through a search API that can be leveraged within whatever application people want to use. So say, for example, you're an editor and you work in Adobe Premiere or in Avid or in Blackmagic Resolve. You can now leverage the search capability within the application itself, which means you no longer have to rely on going to a media asset management system, finding the clips you're looking for, exporting those clips, then re-importing those clips into your editing system just to use them. Now you can surface those clips directly within the application that you want to process the files with, and it makes it for a much more efficient process, much faster. And because we use natural language processing, you'll now find things that you thought weren't there, or you weren't asking for them correctly, so you're getting incorrect responses. There's no more Boolean search required to find the value in the media. So this idea of indexing media is extremely important, especially when you have a lot of it. And the archive itself is only as good as this index. So we have many customers who have many, many petabytes of media out there. And some of it is multiple versions of the same thing. It could be localized versions of a given title, for example, all the different foreign language versions of something. But it's difficult sometimes when you have these massive archives to know where there's duplication. So we have a lot of ways to be able to detect duplication and help call out some of this derivative material so that you can make the footprint of your archives much more manageable, if you will. And then we also talk about preservation storage. We have a number of strategies we talk about creating preservation masters, especially for videotape, where we can remove all of the compression codecs for both the audio and the video so that we can have a true archive representation of that media that could be read in the future. And then finally, the third phase of what we talk about with archive migration has to do with how we leverage all of these assets. And so I'll talk a little bit more about that in a second. So as I mentioned, we have all these different types of media, whether it's film or videotape, audio tape. We have lots of media on data tape right now, both LTO and T10K and some other or older formats like DLT, DAT. So there's media all over the place. And so trying to get that stuff off of this legacy media, which is non-archival, to bring it into cloud, which is archival, and make sense of it is one of our key missions when it comes to this digitization phase. Then when it comes to generating the assets, metadata, we use the various tools we have in our AI and ML tool set. As you can see here, we generate the proxies, as I mentioned, we index that media, and it's all fairly automated. So when you have a massive collection, you can have a very substantial database that can be searched very quickly using natural language processing to find the material you're looking for without really any hiccups. And then finally, leveraging the content, especially to get this to the public. We find that the metadata is actually very useful in direct-to-consumer plays where people are looking for a specific thing. They may not be able to remember the actor's name, but they might remember the character's name in a show. So all of this metadata can travel along with the media that would make it easier for the consumers to find what they're looking for, just like the power of a Google search. And then, of course, our ecosystem wouldn't be the same if we didn't have all these great partners to deal with. So we have all of these wonderful content management and archive migration partners that we work with regularly to help leverage the ways we search this media, the way we tag the media, the way we store the media. So we spend a lot of time with our various customers and these partners to really integrate and find the best solutions for folks to be able to manage their massive media archives. Now, today, we have a very special guest with Dan Lin from ViacomCBS, and they are leveraging, at Viacom, they're leveraging Google Cloud's advanced analytics to enhance their content discovery. And they have lots of media from lots of different sources. And so Dan is here to talk a little bit about that. But I just wanted to point out a couple of key things here. Certainly, with the content recommendations, there are over 4.2 million customers per day looking for recommendations. It's possible now to provide actionable insights for both marketing and the ads teams to be able to analyze, in this case, 2,500 pieces of content daily. And we deliver in-house solutions for AI and ML, which help leverage Google Cloud products with just a few developers in-house. So leveraging the power of AutoML and some of the other partner tools we have, people now have the power of ML training their own models without having to be data scientists. So without further ado, I'd like to introduce our very special guest, Dan Lin.
Thank you, Buzz, for the introduction. So I'm going to sort of walk through a little bit about one of the projects that we did with Google. It's part of a much bigger journey that ViacomCBS is undertaking, sort of our journey to the cloud. This project that we did with Google is specifically around Viacom's content. ViacomCBS has a lot of different content, both on the television and film. In the case of film, it's Paramount Pictures. So this project that we're working on is specifically around the Viacom. So what we're trying to do, I'm going to walk you through sort of a little bit of project overview and talk a little bit about the business requirement and sort of the architecture and how we accomplish this. So first, the project overview. So we have roughly 17 petabytes of content. And these content, kind of like what Buzz was mentioning, is a lot of our sort of source content and where all the derivative assets are generated for ultimately for distribution and packaging to multiple partners and suppliers and then vendors and so forth. So we call these the content submission master. So the idea of this sort of cloud journey is to move all these submission master, at least make a copy of it, put it in the cloud so that can be easily consumed. So it's sort of relatively early part of the sort of content supply chain. And once we are able to put all these content in the cloud, then it will be readily available for transformation or distribution and so on and so forth. And as well as all the other sort of AI, ML things that we like to do with these contents that we weren't able to do before on-prem. So let me kind of talk a little bit about the business requirement for the cloud migration. So the total amount of asset we were talking about for this project was about 14 petabytes of content, and we needed to do this in roughly 4-month period. Besides moving a copy of the content to the cloud, we need to make sure that the data integrity is maintained. And there's really 2 parts to sort of the data integrity. One is making sure that the content that we, while during the transfer process, is not manipulated and is identical to the original source. So that's one aspect of the integrity. The second aspect is that the inventory is complete, right? So we did not miss anything. So every single piece of content that we're supposed to move to the cloud, a copy got made it to Google. Lastly, if there's any exceptions as a part of that transfer, we of course need to be able to easily identify those and then remediate them accordingly. So some of the key questions that we needed to sort of address is what's the best way to move that data in that short amount of time, And there's a couple of things that we looked at. One was TSOP, which is basically the Google transfer tool. Another method we looked at was transfer appliance, and then which is where they're shipping essentially large hard drives, and then we have to put it into the data center, move the data onto these hard drives, and then ship them back to Google, and Google will suck it into the Google Cloud, right? And then the last option is the GSUtil, which is sort of a command line option. Other things that we have to make decisions about is where do we store it, what tier do we store it? Obviously depending on the tier and so on and so forth, and where we store it has different cost implications. Lastly is how do we protect the data? This data is sort of the source asset, so we need to make sure it does not get unauthorized access or gets tampered and so on and so forth, right? So how do we go about protecting this data? And some different types of sort of aspects of that data protection is, do we turn on things like versioning? Do we end up using bucket lock or object lock? Which we end up not choosing to do, as well as who has access. And that's basically the IAM roles. Lastly, sort of from a requirement point of view, we also want to make sure this can be done relatively easily with minimum labor, just because, again, ViacomCBS is a very large content media company. We have a lot of content, and this is just the first one of many. So we want to make sure that this process and the tool that we chose are efficient. And another part is that whatever software we choose to use to do this transfer and manage the transfer and so on and so forth, as new requirements come up, new features can be added and can be deployed and so on and so forth. And so that's where the automated code deployment comes in. So conceptually, essentially all these data are on LTO tapes, and it's actually being supported by Diva. So we actually basically need to pull all these data out of Diva from Portion, which was acquired by Oracle, and I think lately also spun off to Eco Digital. It's a very popular MAM system that's used across many media entertainment companies. We're going to load it onto a local SAN storage, and we're going to use essentially the TSOP software to eventually move these data to Google. So the primary consideration on why we chose TSOP was basically that TSOP handles a lot of the management for us, especially in terms of validating, making sure the data is, the integrity is maintained, that is relatively easy to operate. There's not a lot of people that needs to get involved in staging or destaging equipment and what have you, or loading and unloading data into physical equipment in the case of like the transfer appliance. And so TSOP was sort of the obvious choice. It has a combination of ease of use and least amount of sort of manual intervention required. And so that's kind of why we picked TSOP. So beyond using the TSOP just basically handles the data transfer. I'm going to talk a little bit about the sort of architecture. What's important is that when we're moving all this data out of Diva obviously is carry over some of the proprietary things that's specific to Diva. Part of what we want to do in the project is not carry any sort of technical debt. So information that's very specific to Diva, for example, how objects are referenced and so on and so forth, we want to change the architecture such that we're using sort of more native GUIDs that, more conform to sort of modern architecture, right? So not only do we do the data transfer, we actually did a lot of manipulation in terms of file names and so on and so forth, so that by the time it gets to Google, it doesn't have any of the historical information that's specific to Diva. So one of the things that happen, you'll see this workflow. I won't cover all of it, but you'll see all the other things that we did by leveraging things like BigQuery, and some custom stuff that's written to basically do all these manipulation and processing. Married with TSOT was how we were able to manage the whole data migration to Google. So with that, this is sort of the conclusion of this particular project. We were able to achieve this in 4 months. One of the key reasons that I think is worth pointing out why we chose Google out of all the other vendors, that there are 2 key things that we thought that set the Google, especially the S3 storage apart. One is the fact that regardless of the tier of storage, the access is always instantaneous, whereas some of the other providers, if you store it on colder tier and you need that piece of information, it's not necessarily instantaneous. The second thing that we thought sort of made Google stand out in this use case was the fact that there is a special sort of continental bucket that we are able to store to. So in a scenario where we have assets that we need to protect it and have multiple copies, for example, so that's not subject to sort of localized failures, we do not necessarily need to make full copies on, for example, 2 availability zones or regions or whatever. There's a concept of a continental region. So effectively, that will allow us to achieve that requirement, but without having to pay double the copy, essentially, with another provider. So those are actually the key reasons why we picked Google for this project. So in summary, we were able to achieve this in 4 months with a lot of help from Google. It was a great partnership. This is the first of many sort of content library migrations. And as we speak, we're now moving on to sort of the next one, which is Paramount Pictures.
Well, thank you, Dan. That's great. And it's a very nice description of how you did this. As you can see, this is representative of how ViacomCBS is managing their massive archives. But Dan, in your experience, you pointed out a couple things here I wanted to ask you a little bit about is the integrity checks, the checksums part of this. It's an extremely important part of any of these archives. And if you talk to any archivist, whether they refer to it as a checksum, an MD5 hash, or fixity, everyone is concerned about checking the file integrity of what those files are as they're stored in cloud. So could you talk a little bit about that process? Is that a fully automated process that's part of your MAM, or how do the checksums happen over time?
Yes, it definitely is. So the way we do it today, like I said, a lot of stuff is stored on LTO. So, LTO has a certain life cycle, essentially, if you will. So we have a business requirement where every year we're actually pulling back every piece of asset and rehashing, basically read the content into memory and comparing the MD5 against the original source. And that's how we make sure nothing got changed. And obviously, if there's anything that doesn't match, new copies get created. And most of the time when things don't match, it's due to sort of bit rot or whatever, right? So it definitely does occur, especially given the amount of content that we have. Obviously, in the grand scheme of the population of content we have, the amount of bit rot is actually very, very small. But we want to make sure we copy, we're catching those so that we always have confidence in our content, especially on the film side, which the content sometimes can take hundreds of millions of dollars to make. We definitely want to make sure those content are not contaminated in any fashion.
Yeah, that's a very good point, because a lot of the archive media that's been used to date is somewhat fragile, right? And so I imagine prior to this, you had to have a migration strategy to get from for example, one LTO format to the next one just to be able to preserve the archive at some cadence. But now, um, once you've moved things to cloud, I think that you can breathe a sigh of relief that you don't have to do those migrations anymore. But this also speaks to one question I had is about with a company as big as ViacomCBS, you're dealing with a number of different libraries or archives from different entities. And it seems that those can be somewhat uniform within the company, even though the assets came from disparate locations. They probably came with all manner of metadata or no metadata, who knows. But are you seeing this as an opportunity to create a uniform database of all of this media that you now have within ViacomCBS?
Yeah, that's definitely the idea. I mean, it runs the gamut. I mean, typically the amount of metadata that we have and maintain, it's really a function of multiple things, right? But one of the things that is definitely very much aligned to is the value of the asset. Typically, the more valuable the asset, the more effort was put into maintaining the metadata and cataloging, in the content. We also have content that's sort of pre-finished work as part of the production process or what have you. Especially 10 years ago, 20 years ago. Again, now everything is digital, so obviously the level of catalog varies, right? So as we migrate more and more stuff to the cloud, and we're leveraging things like AI and ML to do things like automated video and audio conformance and what have you, there's also a lot of opportunity to do sort of auto metadata tagging and so forth. Again, a lot of our legacy contents that maybe doesn't have the same amount of richness in metadata, right? And as we do more and more of this, we will hopefully be able to monetize, identify new operators on how to use, especially, content that we haven't touched in a long time.
Yeah, and to that point, final question is: you mentioned the notion of the different tiers of storage we have at Google, and how your retrieval times are the same time to first byte on each tier. Uh, in my experience, I'm noticing that a lot of companies have their archive is not a static thing; it's an actually living, breathing thing, and you're constantly finding ways to monetize what's in there. Is that part of the strategy at this point with ViacomCBS? Is to start leveraging some of the older content that's been sitting in the archive that may not have been as visible or as searchable in the past?
Yeah, I mean, it really runs the gamut. I mean, again, we have things that are like the raw, and on the film side and the television side, it's actually quite different. On the film side, we have things that are, for example, preservation master, which are the original raw DPX files. We probably won't be necessarily working a lot against those type of files per se, right? In that space, we will probably use sort of like a mezzanine format, so they're legacy sort of mezzanine sort of content that we might do the things that you're talking about.
Mhm.
Um, but who knows, right? In 5 years, 10 years, the thing that seems to be relatively constant is that the quality of the content that people want to seem to work again just keeps going higher and higher, right? So maybe somewhere down the road we might be working directly against the original preservation masters.
That's great. Well, Dan, thank you again for your time today. Thank you for contributing to this, and thank you for working with us. So this has been such a great project, and we look forward to many, many more. So, and thank you all for listening. And I hope you found this useful and entertaining. And expect more to come from ViacomCBS and Google Cloud.